a long road and then you get the big bar.
Hey, how's it going?
Good. How are you?
Did I make a Zoom meeting?
Probably.
I don't know if I should make one if you just look on my laptop. I don't know, how much were you briefed on the project?
Not a lot. I think maybe we can just like start
Yeah.
from scratch.
Sure. I'm sure you're briefed on like whole team maintenance tools,
Yeah.
GSS, that whole spiel.
Yep.
Okay, so the goal here is, are you familiar with LVM at all? See if I can find a video on. So Amazon has this thing called sub same day.
Okay.
Maybe not. Well, it's kind of like that. So, in like as a general overview, Amazon removed the idea of having people to go get things. Like they store things
Yeah.
not in specific locations. Now the storage comes to them.
Right.
Right. So if there's a manual station where someone is loading and scanning stuff, the items come to them.
Okay.
Through the robots, right? The robots
Yeah.
go pick it up and they store it on the floors.
Yeah.
A lot of terminology to if you miss
I
something.
know. But yeah.
Um,
Yeah, this week has been mostly just learning all the terminology.
yeah, there's a ton. So these yellow ones are called fabric pods,
Okay.
and that's what Amazon has commonly used everywhere.
Mhm.
Like that was what their starter. Initially, the company was actually Kiva Systems,
Okay.
and then Amazon acquired them, and then they became Amazon's only customer, and
Yeah.
then eventually Amazon Robotics.
Right.
And that was what Kiva specialized in. So
Okay.
they built these fabric pods where humans would place, like they'd scan the item, the system would know what item it is, and they'd place it in a specific cell inside each pod.
Mhm.
Each pod has its own ID,
Yeah.
and the robots scatter across the floor. And then when someone orders that, the robot will go pick it up and bring it to the person so they can scan it out, right?
Got it. Yeah.
And so Kiva started with just the drive units. I'm sure you've seen.
Uh-huh.
I think they started with H drive, or no, they started with S and G. Some naming schemes.
Yeah.
They had small version and big version.
H drive is the one that's being used the most now.
Yeah,
right?
it's
orange.
the most common one, and that's the one that Amazon made after acquiring Kiva.
Okay.
So it was like the first official Amazon robotics
Got it.
drive.
Uh-huh.
Okay, and H Drive Hercules picks up basically all the pods that exist,
Okay.
most of the pods that exist. So these fabric ones are fabric because the volume inside is not static.
Mhm.
Because the fabric can stretch and conform,
Okay.
you can really stuff the volume with whatever you want, right? Like
Got it.
books are lying like this. You can
Yeah.
the human has the dexterity to move it and stuff more.
Just
in,
stuff more stuff. Yeah.
right? And so they have most of the fabrics have these things called retaining bands,
Uh-huh.
which are basically just big rubber bands on each shelf,
Okay.
so that they're stuffing these things so much that they're gonna fall
they're
out
gonna
when
fall.
dries pick it up. So
Okay.
that's what fabric pods
Oh
are.
yeah.
In the last couple years, Amazon has been transitioning more into totes.
Mm-hmm.
And all their automation is on like tote stuff. So if
Right.
you've heard of Totasers, that stands for tote automatic sortation robotic system. I think it's
That's the Cardinal and the.
Cardinal doesn't do so. Cardinal does OBDA, outbound dock.
Okay.
So there are like two main avenues.
Mm-hmm.
There's Proteus, Cardinal. Yeah, Proteus and Cardinal do outbound dock.
Okay.
So after the item is already packaged in
Uh-huh.
the Amazon cardboard boxes or the Jiffies, the styrofoam bubble wrap ones,
Uh-huh.
they're called Jiffies, I think.
Okay.
After they're already packaged,
Mm-hmm.
Cardinal is the yellow arm that is in a cell with 4 different locations next to it, so it's in
Uh-huh.
the center, and it'll pick them up and scan it based on zip code of where the item is supposed to go and
Yeah.
put it in the blue carts.
Okay.
I don't know if you've seen them. They're called go carts.
Probably not.
Next to Arcade, they used to be
Okay.
it, but they're taking it down for some reason. But actually, right across from Arcade, if you see that one blue cell,
Uh-huh.
that's Cardinal.
Yeah.
And so they have those blue carts that will go to the trucks that go to your zip code.
Okay.
Or they go to the delivery centers that then go to your house.
Yeah.
But they're sorted based on zip code.
Mhm.
And so those blue carts, sometimes humans go and pull them.
Mhm.
But most of the time, Proteus, that green drive unit,
Yeah.
will go pick them up and then take them to the trucks.
Okay. So Proteus is only doing outbound.
Outbound dock,
Okay.
yeah. And Proteus is the only drive that is autonomous.
Okay.
And can work in open field,
Mhm.
so it senses humans and all that stuff.
Yeah.
It does have its own fiducials on the ground to know its location, but it works outside of fiducials.
Okay.
All other drive units have the grid system, the fiducials,
Uh-huh.
that they know exactly where you are, and
Yeah.
humans aren't allowed to enter while it's
Right.
on.
Okay.
So now with the toe tasers, a lot of the robotic arms are working towards the toe tasers stuff. So the volume is now rigid, and so the way they want to maximize the volume is by consolidating items. So Sparrow
Okay.
is a robotic arm that can manipulate specific objects inside the totes. So the totes will come to Sparrow's cell.
Yeah.
Sparrow will see one tote with 3 items and one tote with 1 item. It'll take the one that is alone and put it in the 3,
Okay.
so that this tote is empty for more things.
I see. Got it.
So Sparrow's really good at
Okay.
consolidating.
Uh-huh.
And so H Drive picks up totes and fabric now. So now there are 2 systems of storage. There's fabric and there's totes, and H Drive does both.
Okay.
This is all in the sortation aspect. Amazon also has non-sort warehouses,
Yeah.
which is really heavy things that can't be sorted, like TVs or 800 pounds of dog food or something, right?
Got it.
So these big pallets, that's what Titan's for. If you've seen that really big drive.
Yeah.
Yeah, so Titan doesn't have any pods.
Mhm.
It just picks up the really big and heavy stuff, and they're mostly in non-sort. And there are only a couple, so Titan is not very widely used as
Okay.
much as H Drive is. H Drive is used everywhere.
So, quick question. So, for both the fabric pods and the plastic totes,
Mhm.
do they both use the same framework, to go on H drive?
The pods are very similar, but they're not the same.
Okay.
So I have a list of bases. I guess you probably can't see it. They are very slightly different. So there's H1TP, H5TP, HDTP, and Fabric. Those are all the different generations. Fabric is the H pods that are commonly used. The yellow stuff, they're also called Nike sometimes, because I think Nike was the first customer
I see.
for them. HDTP is the ones used in manual stations, so Q6. Houston is one of the big ones. That was where toe tasers officially became like or started launching.
Okay.
If you've seen the like big orange structure that has totes, it's basically it's what separates the totes and gives them to Sparrow or human manual interaction.
Okay.
So it's this big gantry system
Yeah.
that'll pick up totes off of pods and then feed them to the robot, and then pick them up from the robot and feed them to pods.
Okay.
So it's a big gantry with that has like a manipulator that will be able to pick up.
Wait, what is it called?
It's called, the whole system is called totators. I don't know if what that specifically is called.
Okay.
Sometimes,
All right.
yeah,
Got it.
it's a big orange thing.
Okay.
Usually people just refer to it as totasers.
Uh-huh.
I don't know what TCC. That's what it's called.
Okay.
TCC.
Got it. Yeah.
So
Mm-hmm.
this tool is so our team doesn't make like the live GA robot products. We're part of the GSS sustainment and support team.
Yeah.
So we make the tools that RMEs, robot maintenance engineers, use to service the tools,
Okay.
the systems.
Right.
So where I went to South Carolina this last week, right? And they're kind of demoing a new product called LVM, Local Vending Machine. It's like a whole system. It's not really a product.
Okay.
And so I was talking earlier about same delivery. Amazon has this like promise that we can deliver an item that is commonly ordered within the same day.
Okay.
So it kind of bypasses the delivery system. Normally it's fulfillment center, which is where we normally operate,
Yeah.
gets delivered, and then Proteus will take it from the end of fulfillment center to the delivery center, and then delivery center will go to your house.
Right.
Same day kind of bypasses that, and it's called local vending machine because it's multiple floors working on top of each other. Like a vending machine, there's like all these parts are stored, and there are elevators in the center and on the sides that run things through.
Okay. Yeah.
Before, it used to be called RVL, robot vertical lift, where the robot and the pod would go into the elevator and then go to the specific level.
Okay.
So the reason why it's on levels is based on frequency of orders.
Right.
Things that are ordered the most are at the bottom level, so they're most accessible, and then as you get less ordered, the higher it is, right?
Okay.
So they're kind of optimizing on that
Right.
front.
Yeah.
And so it's this like big structure of just like super condensed pods. Everything's really jam packed. And so yeah, like in general, Amazon has like their most common storage solution is pods.
Okay.
All the items are stored in either fabric or totes. They're stored in these big pod farms. Like looks like an airport. If you look down the aisle, you can barely see the end. Like it's massive.
Okay.
So the robots are intended to come pick them up, but a lot of the time a lot of things happen. Pod crashes, so pods hit each other and end up like the little domino. They get each other. They're slightly misaligned, so if they're off the fiducial on the ground, robot won't be able to pick them up.
Right.
They also have weight shift sensors. Robots do. So if they detect the mass is different than what it's supposed to be, then it'll stop moving. So like if something is ejected from the
something falls off. Right.
then so they have all these kind of sensors, and so a lot of things can go wrong.
Okay.
Even if spills happen sometimes, so like the stuff falls on the ground, and like if it's dog food, for example, it's spiral over, they have to go clean it.
Correct.
So there are two roles that like warehouse workers play in these floors: RME and AFM. AFM is Amnesty Floor Monitor. Their main job is to make sure that the floors are clean. Okay. So things that have Amnesty is anything that's fallen on the ground and spilled and that kind of stuff. So that's their main job, and everything else kind of falls under RME, Robot Maintenance Engineer, and they're our main customer.
Okay.
So when we make tools, we make it with the intent that they're the ones they're the user, and so we get a lot of direct feedback with them, talk to them about what they actually use, because RME doesn't answer to us. They answer to Amazon operations. Okay. And so their only goal is, I have this metric to hit from Amazon operations, and if your product doesn't help us meet that goal, we're not going to use it.
Correct. Yeah.
Right?
Yeah.
So, for example, one of the other, the tool I made when I had first rejoined was a wheel removal tool. So wheel had like basically friction welded itself onto the motor, and the only way to remove it if it like something got jammed or something was RMEs were taking a hammer and like smacking it at the end and having it fall off. They're gonna do that because that's the only option they have. And safety came to us and were like, this is not okay.
Yeah.
Make something. And so the first version that I had taken over an ex-employee's job. So the first version that I had finalized from him, it was like 15 pounds or something. It was like a little dumbbell, basically.
Right.
And the general feedback was, this is really heavy. It works, but nobody's going to take it from their like tools cage for 15 pounds and carry it all the way to where they need to. So they're like less likely to use it.
Yeah.
So then the next version ended up shaving like half the weight. So like that's kind of what we have to look at.
see.
We get a lot of user feedback directly from armies, and it's very beneficial to actually use the tool yourself and see what is nice to use, because at the end of the day, if it's not good, even if it works, if it's not helpful, it won't be used. Right? So back to this project. Overview for what this is initially was meant to do was for in LVM, the pods need to enter this whole like vending machine system in some way.
Okay.
And so the robots won't be able to do it because actually in RVL systems, but eventually the robots won't be able to do it. So they're manually moving pods in there.
Okay.
The existing solution they had was a pallet jack with a like large welded structure on top of it, so that they could move the pods on wheels. They'd be able to put the pods on wheels and put them in the right spots. The issue with the pallet jack is it's super long, right? You have the full handle, really large, bulky, hard to maneuver, and it just wouldn't fit inside the hive. The hive is the LVM structure. Okay. It's really dense, like the most, more than any other pod farm.
Okay.
And so actually recently talking to some armies in Q6 when I was there for some training, they said that that's currently what they're using outside of our prototype. And for them to be able to service a pod that is like damaged or stuck or they need to move it, have to clear out an area to bring the tool in. Right, so the goal here is to get a manual tool that will go under pods, lift it up onto wheels, and then be able to maneuver it out of the pod farm.
Without taking too much real estate.
Yeah, so real estate's a big factor here. So the intent with the tool at its first conception was for LVM specifically, they need a way to induct and remove pods. So if a pod is damaged, they need to get it out of that system, and if a new pod needs to go in, it has to go through here.
Okay.
That isn't the case for most farms. They usually just have like a dead corner where they just dump dead pods in, or stuff like that. But that was initially what the intent was, and LVM only uses H5TP or H1TP, that system. It's a different type of pod.
So like 5 layers.
Yeah, it's 5 LODs, 5 layers of tote pods.
Okay,
yeah, I think that's what it is.
Yeah.
H5TP.
Okay, got it.
So H1TP is 1 layer, H5TP is 5 layers.
That makes sense.
So that's what the initial intent was. And the prototype that I just went to South Carolina for to retrofit the first prototype was just to tackle that. Now in our next redesign that we're trying to, so I don't know if anybody told you about the timeline. We want a prototype of this tool by December or like end of 2025. So we really need the prototype in-house done by like mid-November, so we can do our testing and then deliver it to a site. You've seen the FLX stuff, right? Like how our tools are supposed to look and all that stuff. This prototype is not meant to be FLX. We want to make sure we know it works and our system is good before we make it like user friendly and fit a theme. So that stuff will come later, but like our main goal that we're trying to hit right now is end of November.
Right, a working prototype by November.
Yeah.
Got it.
So we've had various different like lifting solutions. The next version, this prototype, is meant to work with any pod that is lifted by H-Drive. So that's Fabric, H1TP, H5TP, and HDTP. HDTP is 7 layers, and it's not used in LVM. It's used kind of everywhere else. Anywhere where TCC is used, I think HDTP is used. So
what does the D stand for?
Dense, I think. It's dense tote pods or something.
Got it.
Yeah. There used to be DTP, but they phased that out because I think Titan used to pick up DTPs, dense tote pods.
Gotcha.
But yeah, so with those, there are like 7 different generations of each pod, or each pod has different variations, right? Yeah. HTTP has 1 gen that's released, and then 2 generations in the works. H5TP has 1 generation, H1TP has 1, Fabric has like 20, but
Right.
Only like a couple of them are used.
Oh.
So across these, there's only 2 different geometry changes. So actually, let me talk through the tool as it stands.
Sure.
So we want a manual tool that'll go under pods and lift them,
Mhm.
right? So pretty simply, it's like glorified pallet jack.
Yeah.
It's got its own caster wheels,
Right.
handles that'll add. It'll wheel underneath the pod itself,
Mhm.
and then this square creates the top platform.
Okay.
So
So scissors.
yeah,
Okay.
so I have a lead screw right here.
Got it.
That when it rotates, these are all track rollers, and this is actually 2 different C channels that are facing towards each other.
Uh-huh.
So this is the bottom
Okay.
channel, and
Yeah.
this is the top channel, and they're not connected. These are just effectively bearings, track
Yeah.
rollers, that will run across the long flat
Mhm.
face of the channel,
Yeah.
so that when this bar moves in and out, the scissor linkage is activating, and this connecting rod translates the
Mhm.
both of them so that we're working together. Let me see if I have the quip up. So do you have this quip? Do you have our quip
I do.
folders,
Yeah.
right? This is in the Pod Mover Tools one,
Okay.
and this is kind of like the main development one for this tool. So
I see.
timeline, point of contacts. This is the initial one. I can just skim past it.
Uh-huh.
So this is this is the concept of what the prototype looked like, and this is what the prototype ended up looking like.
I see.
So he had these little like cups to be able to pick up the underneath of the pod.
Okay.
But in general, that's like the primary goal. So I have the requirements right here, right? Like,
Got it.
should be applicable to lift up all the pods. Maneuverable in all pod farms. So like the general geometry is constrained by the turning radius.
Yep.
All pods have like highways is what the axis pads are.
Mhm.
So you have to be able to make that turn
Yep.
with a pod on the tool,
Right.
without moving anything else.
Right.
Should provide a brake. Okay, yeah.
Okay, I see. Yeah, sure.
I'll briefly run through the like development
Mhm.
ideas. Initially wanted this like tapered wheel system so that let me show you what it looks like underneath the pod. This is DTP. So I have a configuration set up for the different types of pods, but because there are 2 different geometries, all I want to do between the 2 configurations was keep the same tool.
Yeah.
But these blocks right here are the centering feature.
Uh-huh.
So I just have like a slanted face on either end, and this little like L cutout
Yeah.
that will locate. It'll center the tool left, right
Mhm.
in the pod, and it'll also give like a locating feature for depth.
Okay.
So you know how far you've inserted the tool into the pod.
I see.
And for both configurations, so you can kind of see, the lifting surface is always centered on the pod.
Right.
So you're always lifting from the center
Mhm.
of the pod. It's just that this block changes so that
Got it. Okay. Yeah.
it works for
Where
both geometries.
Correct. Yeah.
But yeah, it's supposed to be able to wheel underneath it.
Uh-huh.
And I wanted this tapered wheel system so that the inside wheels would be able to fit between the pod legs,
Uh-huh.
but these outside wheels don't have to.
Okay.
Because you're never going to get all 4 wheels underneath the pod, right?
Mhm.
Because you have all this interaction stuff you need out here.
Yeah.
So these 2 back wheels don't need to be outside of the pod, so I spaced them out as wide as possible.
Gotcha.
That was kind of the driving idea behind that.
Uh-huh.
Ergonomic handles. Ergo has plenty of suggestions for
Mhm.
how tools should feel. A lot of the time we not bypass it, but it is, and it's also not a lower priority, but it's definitely like still a suggestion, because at the end of the day, these are like warehouse workers. They're
Yeah.
not sitting on their computer the
Right,
entire time.
of
So
course.
ergonomic
Exactly.
isn't at the same standard.
Yeah.
So ideally, we want to, like, they're at the end of the day suggestions.
Mhm.
I don't know. They'll probably get mad if I say that. But that's what the handle should look like.
Yeah.
And I have a picture of what the handle. Actually, I don't know if I sent myself the tool. No, I didn't. I'll show you a picture of what the tool looked like.
Okay.
For centering feature, I was thinking of different things. Ended up not going with any of these, and just the guide blocks worked pretty well. I just explained them. For the lifting, talked about scissor linkages. Initially, we were looking at a lot of the stuff we were looking at. Initially, were foot operated because of the space constraint near your handle.
Okay.
And you know, most foot operated lift tables are hydraulic.
Yeah.
The reason we can't go with hydraulic is because EU has compliance constraints on oils.
Okay.
So to make this product global, it has to fit EU oil constraints, regulatory stuff.
I see.
And it's really hard to get a hydraulic jack approved.
Oh, wow.
So we wanted a completely mechanical solution, and so I was looking at mechanical jacks, and so this railway jack is used in train tracks. They're able to go but super long lever arm.
Okay.
So initially I was looking at making something custom, but I realized we wouldn't be able to hit that by October or November when we wanted to get a prototype done. So,
So when did you get started on this?
I guess July. Yeah, mid-July.
Gotcha.
I had wrapped up. Probably mid-July. At least the ideation maybe happened early July, but I didn't really start until mid-July. The previous so these are just different lifting mechanisms I prototyped and decided not to pursue. Scissor linkage is what we're going with now.
I see.
For perception, so the tool needs to, a lot of the time the pods are misaligned and they just need to be realigned to the fiducial.
Okay.
So their main goal is just to go in quickly, pick it up, and place it down really quickly. To do that, you need to be able to see the fiducial. And so the prototype had a camera and a backup camera, car backup camera, and a laser crosshair. Okay. So turn the camera on.
So you can line it up.
You can line it up super easily.
Right.
It worked super well. Main issue is that electronics is also a compliance issue. You have to get a lot of compliance with electronics.
Right.
But also charging becomes a big issue.
Yeah.
The tools are often left on the floor, not maintained, and not looked at until they need it. And so if your tool needs maintenance, then it becomes less reliable.
Right, of course.
So that's why we wanted a complete mechanical solution.
Okay, yeah.
So we really like the camera and crosshair, but wanted to pursue other options. And that's what this team that I invited you to the meeting today, they're called Tactile. They're a contracting team. I think they're industrial design. Okay. But they're pursuing this idea of a periscope and flashlight. So just two mirrors that are angled like this. Okay. So one looks directly at the fiducial and one is the user mirror. And they'll have two crosshairs etched on the mirrors. So when they both line up, then you know you're looking at it straight on. Okay. And for light, they prototyped a fiber optic cable that runs down. So you can just put a flashlight on top and it'll illuminate the floor. You'll be able to see with the mirrors. Okay. So really cool idea. Yeah. They're leading that design front. And the goal for us is to just get an off-the-shelf part. So they do all the design and stuff and we just drop it into our system. That's the idea.
Make it available for us, but
yeah. So this is the initial concept with a foot pedal to come all the way out here. Different ideas. This is no longer up to date. I did an analysis on how big the tool should be. Different analyses. This is what at one point the tool looked like. Okay. So I wanted one long scissor that ran all the way across. And then after doing some force analysis, the force is the most on the scissor linkage when it's collapsed, right? Because the legs are as low as possible. Right. And so the force was just an insane number if it was all the way. I see. So I ended up swapping it to two small linkages and connecting it so that you could get a better starting angle with that scissor linkage. Yeah. This is just another idea for the frame, an idea for a collapsible handle. This is the force analysis, just linkage and geometry and force to determine what the optimal size is for the linkage, and then the corresponding lead screw. Okay. So just more math in that sense. And this is another calculation to see, because the scissor linkage is moving as it's lifting, the support points is also moving. Right. So as long the support points have to lie within the range of the center of gravity of the pod,
Oh.
so that even when your max lifted,
Okay.
the pod will never try to tilt.
Got it. Yeah.
Right. So
Makes
quick
sense.
calculation on
Oh,
that. And then this is my like notes of I went to use the tool in South Carolina,
Uh-huh.
the prototype.
Yeah.
And these are just my like notes of using it. So yeah, like fundamental.
So did your first prototype also have the double scissor lift?
No, it was this big scissor link, but
Okay.
it was not using a lead screw. It was using a hydraulic. ball
Got it.
jack.
Okay.
And we kind of already knew that the ball jack would be too hard to release,
Mhm.
but this was like a very first quick prototype. So.
Okay. Yeah.
So, with regards to the design decisions on this tool,
Mm-hmm.
normally what we would do for a tool is we would design it with almost production intent, even if it's a prototype that we like intend to iterate on.
Yeah.
We'll get most of the way there and then give it to suppliers so that they can manufacture it, assemble it, and give us a final
What's it
product.
called? Yeah.
But we don't have the timeline for that because
Uh-huh.
suppliers take forever and they do a lot of things wrong.
Yeah.
So we want to assemble this in-house
Mhm.
and order from various suppliers and just piece it all together ourselves.
Okay.
And because, not that I'm not confident in the design, but I know a lot of things can and will change, I'm making it as modular as possible. So
Okay.
no welding, everything's fasteners, and you saw the channels, right, that
Yep.
open up. So these are like building blocks I'm using. It's just aluminum that has. I don't know if I can. Can I just hide one face? So it's just threaded holes on every face,
Okay.
so that when I oh, I don't know how to whatever. It's threaded holes on every face, and it's basically a building block so that every joint I make, I have fasteners, possibility on every
Got it.
face,
Okay.
and I can just make whatever I
Yeah.
want. Like,
Oh, I see.
if I need a bumper for the front of this, I can just put
You
a
can
flat
just-
plane attached
right,
to this.
yeah. Okay.
So,
Makes sense.
also with this prototype, we have the leisure of not caring about weight too much. We want to over design, like we want to do the correct analyses, but
Yeah.
we don't have to make sure and optimize it works.
Okay.
We can over design and then walk it back down in the next version. So all these linkages are going to be steel.
Okay.
I wanted to keep the big frame aluminum because if I make that steel, it's going to be
It's
really
gonna be
heavy.
really heavy, yeah.
So all of this is aluminum 6061.
Right.
These plates can be steel. The linkages can be steel. This is like 3/16 inch wall thick aluminum,
Okay.
but haven't done any analysis on that. But yeah, fundamentally we got 5 inch casters. These casters are special made. This like system is like called a central locking system. I found this vendor that gives you 3 options for a caster. So this pedal goes all the way across both.
Okay.
And then it has 3 positions. Total free, so they act as normal swivel casters.
Yep.
Total brake, so when pressed all the way down, they are completely
fully
locked.
brake.
Yeah, rotation and direction.
Uh-huh.
And then they have a middle ground where it's called directionally locked.
Mhm.
So the wheels can rotate on their own axis,
Okay.
but they automatically snap to front back.
Okay.
So you can push in a straight line. It becomes a shopping cart.
Got it.
Right?
Okay. Yeah.
It becomes 2 fixed casters, 2 swivel.
Mm-hmm.
So this is good for like super long pads when you're walking in a straight line, because one of the feedback was on all 4 swivel casters, because it's really heavy, the whole
Yeah,
tool
it's
wants to
gonna
walk away from you.
okay.
It doesn't
Yeah.
want to walk in straight.
Right. Yeah, that makes sense.
These guide blocks exist to center the tool left, right. These scissor linkages, it's 3 unique parts. So this is one part, the outside piece, inside piece, and then the connecting rod.
Yeah.
Mirrored 4 times. You also, with this 4, you get 4 support points on the pod. So when you're lifting it, the pod's underbelly has like a plus sign. So
Okay.
you're only lifting from like a rectangle here, a rectangle here, a rectangle here, a rectangle here.
Okay. Wait.
Like, so this is what the inside of a pod looks like. You see these?
Oh, I see.
Yeah, so this is technically open air.
Got
I'm
it.
probably still gonna put a top plate on just to keep debris and like pinch points and all that stuff.
Okay.
But the actual strength of the and lifting is done by these
Got
blocks.
it. Okay.
The lead screw is technically cantilevered, but not really. So this is a it's free on this side because it's radially supported by the track rollers. So it doesn't want to go bend down because the track rollers are keeping it up. And then it's fixed on this end, so it can't go. The lead screw itself can't move. In terms of how I want to drive it, here's a lead screw. I want to have a shaft and couple it somehow that comes all the way out here with a pulley that runs up here, and then we need a crank and we need a handle of sorts.
Like a regular mechanical handle.
Yeah. So actually, one of the things we were, let me see if I have Jacob's responses earlier. Well, initially we were thinking, he's the ergo guy, by the way.
I see.
So he pesters me with ergo requirements, I pestered him with these ideas. But we want, like, a ship handle. It looks like a pirate
It does,
ship. But the idea with this is so I did the force analysis, and I don't remember exactly what the number is, but the force input required is dependent on the handle, right? Like, I have a linear force, but the bigger I make the crank, the easier it becomes. So yeah, I got like an input torque required, or wait, the lead screw required. Lead screw has 16 kilonewtons of axial force, and the torque required to operate the lead screw is 54 newton meters. Okay. So yeah, I don't want to change the gear ratio using the pulleys because that's just another parameter that I don't want to have to consider. I want to have the input gear ratio just be on the handle itself. So in theory, if there is nothing else to obstruct it, I could have a giant wheel and then they could just use two hands and then manipulate it. Because the force required or the input force required is also dependent on the load. Right? It'll be super easy to lift if there's nothing.
There's nothing on it.
So with the wheel too, you could kind of just spin it and let it spin until it gets to the thing. So that's why I want to do a wheel. But the issue with the wheel is I have a handle. I need to be able to move the tool. So
also need to take some space constraint.
Yeah. Initially, I had an idea of if the wheel could lock at maximum lift and maximum or like minimum lift, then you can use the wheel as the handle.
Oh, okay.
And then it'll only be able to spin when you're lifting because you're not going to move while you're lifting. And you're not. So.
Well, that's a nice idea.
That was an idea, but I hadn't had time to actually develop it. But so my goal here. Do you have any questions about how the tool?
No, I think so far it's pretty straightforward.
Okay. The goal is to have in order to be able to continue, I have a mock shift bomb set up to be able to order our parts. We're also kind of under budget constraints. I don't know if that you're mentioning. Very recently. They just came out of nowhere and were like, time to stop spending, guys. Nobody ordered anything. So we're tracking all of our expenditures and whatnot. In order to go ahead and start ordering parts, like in my design intent or gut feeling, I feel like everything on this front half is ready to order. Like all these components should work and be able to assemble. But we're kind of not waiting because we want to do 3 analyses to just give everybody the finance team a safe, here, we did the analysis, you should allow us to order it. We want to do a force analysis on the linkage and make sure all of that is structural and will survive the maximum loads.
What's the factor of safety you would normally consider?
It's kind of also a thing we get to choose. What I did was, so the maximum load of a fully loaded HDTP is 1125 pounds. And I threw a factor of safety onto the load. So normally I do factor of safety on the component itself, right? If I'm analyzing every component. But to do all the hand calculations, I couldn't do that. So I just put a factor of safety of 2 on the load itself. So I'm designing around a 2250 pound.
Gotcha.
So on the linkage itself, right? So that's a dynamic analysis. Personally, I'm not very comfortable with FEA. I'm pretty much a novice when it comes to that. So we have a FEA team here that I just need to submit a ticket for, and they said they'll handle that. But I don't know what their workload is. If it takes too long for them, we might have to do it ourselves.
Gotcha.
Another analysis is the load on the casters,
Mhm.
right? Like all the wheels,
Yeah.
all the load is end up on the casters.
Correct.
So these plates need to be rigid enough
Mhm.
on both ends because this is like a giant cantilever
Yeah.
beam. And then the other one was the lead screw brace. Just make sure that this is rigid enough. But that
Mhm.
seems pretty straightforward. It's just I know the axial load,
Right.
so I can just do a bending.
Uh-huh.
Well, that's pretty simple. So that's what's stopping us from going ahead and ordering at least these parts.
Mhm.
And I want to start ordering by early October, so like this week. So I
Okay.
really want everything done in this coming week.
Mhm.
I threw together a task list on Asana. You have Asana and you have
I do,
Access
yeah.
Source. So this is the HBOT alignment tool
Right.
project.
Uh-huh.
And I was talking to Thatcher about splitting. So these are the tasks that we have left.
Okay.
Hand calc. So these are the analyses that I just talked about.
Mhm.
Adding fasteners, I have the holes for it. I just haven't figured out the lengths and then
Yeah.
that stuff. Belts and pulleys, coupler for the lead shaft.
Mhm.
This is the main one that I think. And this. Yeah. We need to do the handle as well.
Mhm.
But I think this is a problem that I haven't fully thought through yet. I know it's a problem, and I think it'll be a good one for you to tackle.
Okay. Yeah.
So, one of the main problems that people didn't like about the other tool was that it looked very similar to this.
Mhm.
Actually, I have the quip right. So, the way this mast is, can you see that? It's an open. This mast is on this big L across from, so like it's
Yep.
it's joined by like a weld right here,
Okay.
and it comes out all the way out here, and so the entire mast, when you try to push the
Push
tool,
it, it's gonna.
the whole thing is bending
Yeah.
before you actually exert any force on the tool. So
Okay.
like the responsiveness of the tool is very small because there's so much
Yep.
play before you
Uh-huh.
actually start moving it.
Right.
So we want the mast to be as rigid as possible.
Got it.
I haven't thought of the proper way to join this. My thought was if you just join it instead of reducing that, if you get rid of that big L
Yep.
and you join it at the bottom where the base is,
Mhm.
then you already strengthen it a lot.
Correct.
One of the other reasons was also because this 1x2 was facing the other way,
Uh-huh.
so the moment of inertia is half, right? Like it's just falling
Yeah.
the wrong way. But in general, I haven't really thought through how the rigidity of this whole system. So this plate needs to be really rigid. The whole mass needs to be really rigid, and we need to minimize as much bending as possible.
All right. Yeah.
So adding ribs, I just threw these 1x2s in there for a
Mhm.
placeholder because we can add ribs and ways to reduce bending.
Strengthen it, yeah.
With almost all of this real estate, the only real estate constraints here are is when it's inside. I guess the HTTP is the bigger one. Yeah, you just can't cross this plane,
Okay. Got
right?
it.
So all this area we can use to actually
Mhm.
make it rigid.
Strengthen the mast.
And to be honest, I think we can weld ribs if we need to, if
Mhm.
it makes it easier, like just a big triangular gusset
Okay.
right here.
Yeah. Something like that.
But
Or try to
I-
find like fastener solutions.
yeah, I think
preferably.
I'd prefer fastener solutions so that we can just assemble
exactly.
ourselves.
Yeah.
But I think that's like the big thing here.
Okay.
Even the distance between these two masts
Mhm.
is not set in stone.
Okay.
You have complete freedom for that.
Gotcha.
But I think that would be a good help.
Yeah, for sure.
On this one, just the caster plate and the mast as a rigid body
Mhm.
need to just be stronger.
Got
The
it.
only constraints is the location of these 12 holes
Mhm.
times 2. 24 holes. Like I want to keep these all the same,
Yep.
but the rest of the material on the inside
Okay.
is free to.
Gotcha.
And even the thickness of the plate, the material of the plate, whatever it needs to
Uh-huh.
be rigid enough is perfectly fine. You have also space underneath.
Mhm.
The only space that you don't have is the swivel radius of this caster,
Yeah.
which comes up to be like right about here. So
Okay.
a
So
circle.
like all of the circle.
Yeah.
area.
So like if you need to beef this up by throwing a bar there,
Mhm.
perfectly fine.
Sure.
On the underside, so this is a placeholder for the periscope.
Yeah.
So we need to be able to view it kind of like this,
Okay.
right? Like a person's going to be
Uh-huh.
holding the thing and they're going to be looking down
Yeah.
into the periscope.
Mhm.
So this area needs to be semi-clear.
Yeah.
Ergo has a requirement for foot clearance. So when you're pushing carts, they need to make sure you're not like kicking the cart as you walk.
Okay.
So what that ends up being is kind of like two rectangles of no-go zones, because that's where your feet would be, right?
Got it.
That is kind of what it ends up being.
Mm-hmm.
I actually need to change the foot pedal to work around that, so I'm planning on like bringing it out here and then coming all the way out here.
I see.
Because right now it's gonna hit, yeah. So I think that's the biggest one. But here, let me just show you what the task lists are, and if you think you'd be really helpful at one of them.
Yeah. Also, like, can you show me where I can find the file in PDM?
Yes. So this is everything that I've done so far is local. I did a pack and go on the 15th of September to give it to PD, but this is where it is right now. And if you need a more up to date pack and go,
Yeah.
I'll send it immediately.
Done.
Oh yeah, tasks. So to complete this by the 26th, this is what we really need. The lifting mechanism is basically done.
Okay.
Do you have like any immediate like you think should change or should be considered when it comes to like
The lifting mechanism?
Yeah.
No, I think it looks pretty good, actually. Yeah. I was actually wondering why not just a single scissor, but
yeah,
there
the
seems
force
to be-
the force when this
Yeah.
scissor linkage all the way across is
that makes sense.
yeah. I think what I do want to do is I want to drop this down further so this sliding 2x1 sits a little higher because the periscope, I don't want it to rub against the periscope.
Okay, yeah.
So this small item I'll do.
Yeah, can you go back?
Yeah.
Oh,
So these are all.
yeah, that is kind of...
So this is dead axle, right? This axle threads right into the channel.
Yeah.
This axle threads right into the channel. These are all live, so
Right.
they pivot around each other.
Uh-huh.
Technically, I could have made this one dead axle too, right? Like if it doesn't pivot around this bar, but only pivots around here. But I had thought of that after I finished the section. So these two are live. They're all retaining rings and plastic bushings. I'm using a lot of bushings, but they also act as thrusters. They're all flanged, so they're keeping the space up between everything.
Right.
My idea here is that we kind of assemble these in kits and then drop it down and thread these two in.
Got it. Okay.
This slot is just a through axis slot, so that this pin can. Well, actually, I'm not too confident in this section. So this is one long bolt that runs through this.
Okay.
Wait, is it? I don't know what this. Yeah.
Yeah.
And oh no, this is a threaded standoff or something.
Okay.
I think this is
With
one
like
of these.
two bolts, right?
Yeah, I think it's just another like axle and threaded fastener that ends like right here. And on this side, I have another fastener coming in from this. So this is a through hole in this tube attachment.
I see.
Does that make sense? So yeah, that's how I'm doing that. I'm not the biggest fan of that, but I think that's like a okay solution. We can think of something later. On this end, I need to like make a coupler and then figure out the belt's length and all that.
Yeah.
So yeah, task list.
Okay. Yeah.
Stiffen caster
Awesome.
attachment, stiffen mast.
Yep.
The quick analyses that have that. The fasteners, it kind of needs to be on the top level assembly, and it's also not super important, so I threw that on myself.
Right.
But do you think this is something
I
you
think
tackle?
caster point force analysis. Okay. Yeah.
So the beam bending one was just this channel strength, just like a quick hand calc. That's like
Okay.
the load is right here. It's supported up here and it's supported all the way here, but this length is unsupported. Will the bending? Will it survive the bending?
Right.
Pretty simple hand calcs. We do a lot of like rough FBDs and that kind of stuff just to get it fast.
Yeah.
This stuff is just kind of I already selected the final casters, but the lead time is really long. I think it'll come like end of December. So I'm gonna buy temporary casters that are just swivel, super cheap, that are 5 inches as well, so that we can just drop it in, build the whole tool, and then whenever those come out, we can
Swap
swap
more.
it.
Yeah.
But the attachment holes will be slightly different, so I just need to
Yeah.
put some holes.
Okay.
It's not that deep. swap the lead screw with the angular contact bearing. So right now, the lead screw I'm having, this is a flange bushing with a washer and a retaining ring to fix it.
Yeah.
But I've heard of angular contact ball bearings that have a lot longer or larger thrust load. So I'm gonna swap to that and then have like a thread nut on the other end to fix it in place.
Got it.
So that's on the power transmission side. Pulley, belt, shaft coupler, and then on the input side, handle, crank, and crank receiver. The crank receiver is because we know Ergo is most likely not gonna like whatever crank we make or wheel we make.
Yeah.
So if it is like somewhat slottable, then we can just continue iterating on the handle and the crank while the rest of the tool stays the same, so we don't have to keep making parts. But honestly, I don't think we need to do that either, because this 1x2 is kind of the handle receiver, so we can just swap this plate out and put whatever you want here. Another idea I had actually that total freedom to do is, instead of using 2x1s, if we just had open channels that go up as well, then you can secure them with large plates. Like, you can just have a plate that runs on both sides, and then this hardware, for example, can sit in the center of this plate and you have bearing on both sides to capture it. I think I actually prefer that. I'm not sure. What do you think?
So like just have open channels running up and...
Yeah, so open channels that face each other as the mast, and you can join them wherever you want with the plates.
Top plate.
Yeah.
Yeah.
So then you can add whatever hardware you want. Like this pulley and belt can sit inside.
Exactly.
This,
Yeah. No, that makes sense.
And be
so
secure.
Right now, is this like a rectangular channel?
Yeah, this is just a 1x2, a hollow.
Okay.
I just use whatever I was using elsewhere, so it's just 3/16 inch wall. So yeah, I'm actually not the biggest fan of the way the mast is right now.
Okay.
If you like that channel idea, I think it'd be stronger too, because you get to make it longer, right?
Yeah. And then you can just insert it inside it.
Yeah. So that's kind of the tasks left. I think doing the stuff I talked about, like the rigidity of this whole section, if you tackle that front and then I tackle the power transmission side, the belt and that stuff, and then we can come together and then build the handle and wheel, because that has to be done after the mast is done, basically, right? So yeah, general like timeline is I want to get those done, have design done by 9/26. I'm okay if it takes another week. And then FEA, make sure we're good to go and order before the 15th. I'm actually going on PTO for like 10 days on the 15th. So I want to order as much as possible before then, so that while I'm out, we're just waiting on parts. Right. So it's not what's driving the timeline, but it would be a good use of time if
you can get out for it. No, for sure.
Then
makes sense.
But the main driver for the timeline is we want to deliver one of these by December 2025. So we need to do our own internal testing and make sure it's good to go by like November.
Makes sense. Yeah. Okay. November.
So I think we're good on time.
Yeah.
Actually, this
is like 4 weeks from now.
Yeah. I think we're. Oh yeah, maybe you are not that good at time. In mid-November, late November.
Yeah.
The tool went through a lot of different ideas by the frames. I don't know if you could tell. I actually only came up with the double channel with the track rollers. I think this Friday. Yeah, on the 5th.
I see.
So,
Is there like a video of the version 1, like into LVM? And
yes, I have a video on my desktop of me using it. Maybe some Word docs as well. This is the final.
I see.
This is the video I want to. No, that's the wrong video. Is this the? Yeah. But yeah, I am not the biggest fan of the foot pedal. I think it's not very ergonomic because you're standing on one leg while you're
And
pressing.
then, yeah, exactly.
So, everybody's doing their Asana updates, but I already did, so I don't know if I should do it. I don't really have anything to update. This. Yeah, with the development before Thatcher was like, "Hey, maybe we should stop spending." He was like, "Yeah, we really want to push forward on this. So what if I told you weight was not a concern, cost was not a concern, just go make something that works?" I was like, "Say less.
Okay.
I'll do that." And now cost is a concern. Okay. This is normally not part of the use case. You would usually wouldn't load it into. So this is the like LVM. You see the multiple layers.
Yeah.
So I'm moving the tool. There's like a ramp to the elevator. So
Let's see.
this is the elevator that takes stuff in. Pushing it in. Going up the stairs. Oh yeah, you're supposed to pull the tool. I didn't realize that when I was testing it myself. You're not supposed to push the tool because when the pod's already on it, you can't see anything.
Okay.
So you're supposed to pull it over this transition plate. So this is in Boss 27, the Westboro office.
Okay.
And they have a mock shift LVM, so they don't have like the full scale one. They build like a small. So these are the braces that you have to kind of fit through. And this is kind of resembling. So I'm trying to get the pod into this one, so I'm starting to turn before, but the handle right here, it just hit that pod.
I see.
Or I hit that toe. And I have to be sideways to be able to insert it. That stuff is not like addressable. The pod takes its own geometry up, so the only like thing you're designing around is how much space it takes off outside of the pod.
Yeah. Okay.
Right.
Yeah.
So I don't know if they go in, but once I decide it's aligned, you see how much this is bending before it even pod moves.
Right.
These are also really tiny caster wheels. These are like 2.5 inch wheels. I bumped mine up to 5.
Okay.
So it'll make it rolling a lot easier and the micro adjustments.
Right. Gotcha.
So once it's set, there's a bottle jack right at the center. I don't know if it lets me drop it. Oh, we didn't drop it. Maybe at the end. No. Okay, that was just the movement then. But there's a bottle jack at the bottom.
Okay.
So when you go to release it, oh yeah, you see that red handle?
Yeah.
You get down, you use the bottle jack, release the pressure, it'll drop down, and you tighten it back up so that next time you can pump the foot pedal and lift it.
Got it.
This is the handle I was talking about. So you have the double uprights, these two ones. That actually made it super useful to like, it was super ergonomic. You had plenty of options.
I see.
This one was that weird, like 45 degree, I don't know. It's like this. I didn't really like it. It also stuck out, like,
that's
too much.
It's a lot of space.
Yeah. So.
Okay. All right.
Yeah. Where are you touring apartments?
In around Wakefield.
Okay. Astor at Wakefield?
Not particularly that one. I'm going to Nexus.
Okay, I don't think I saw that one. I moved in May and I was looking at I think Astor
Astor?
at the Wakefield Summit. I ended up moving into Emery Flats at Woburn.
Okay.
So it's like I think 5 minutes more north from
Gotcha.
Wakefield.
Okay.
On 93.
I see.
So yeah. I'm like an 8-minute drive from work, which
That's
is super nice.
Yeah, I know
Like,
for sure. That's kind of what I was looking for too, like something in between Boston and the workplace.
initially, I was looking at Medford area.
Uh-huh.
So I weighed like, do I want to be right on the green line
Mhm.
for like a slightly longer commute,
Yeah.
or do I want to be not? But I ended up. I'm pretty glad with what I chose.
That's it.
The 8-minute commute.
For sure.
I'm just so less exhausted. Whatever.
I know. Yeah. Yeah, like right now I'm at Lowell. It's like 40 minutes.
Yeah. When I was at co-op, it's nice.
Oh, yeah. So you ever like go work out of like Seaport or other?